Those rhizomes are storing the two things that plants need: starch and water. Okay. Tuber. So I brought show and tell. Tuber. Here, pass it around. Potato. Okay, a tuber is a stem. We know it's a stem because each eye is a node. If you leave the stem, if you leave the tuber sitting long enough, it will start to sprout. What do we find inside a potato if we cut it open? Starch and water. We just happen to like it because we're animals. Okay, so each eye is a node. You leave it long enough and it will start germinating. Like that. Hopefully that's not what your refrigerator looks like. Okay, then a bulb. Onion, here's a bulb, modified stem surrounded by modified leaves. You cut the bulb open, you see it actually is a small stem area, and it has thick, fleshy, modified leaves around it. So a bulb is a modified stem. There's another one that's germinating, you can see. Leave that long enough.
But I did
See,
figure out my
this is
bananas
kitchen
a
science.
monocot.
See what happens. A corm. We have lots of corms around here. Corm is another type of modified stem surrounded by not fleshy leaves, but thin, papery leaves. There's a cross section of a corm. And what is it that has the good corms? Is it purple coneflower? Where's the good corm around here? Nancy, do you remember? What has the good corm? Purple coneflower?
It'll come floating back.
Okay, okay. Just yell it out when it gets there. All right, there's another one. Okay, this is where the tillers are. Okay, a stolon is an above ground growing stem used for propagation. And so, what plant is that?
Strawberry.
Yeah. That's what the plants use, the tillers. A tendril, modified stem for anchoring. Or the Virginia creeper or grape, it's a modification of the stem. Cactus. Cactus is interesting in that the photosynthetic structure of a cactus is actually its stem. Its leaves are the spines of the cactus. So the cactus pad is photosynthetic. The cactus leaves are protective. So what is the cactus pad trying to protect itself from?
Things that want its moisture.
Yeah, it's protecting itself from herbivores.
Mule deer.
People. Okay, so leaves. Function of the leaves, this is our third organ. Photosynthesis, storage of water, and protection. We saw how leaves could be protective. But photosynthesis by far is the most important part. And when we were talking with Dr. Blair, he showed carbon dioxide levels over time. And he showed that the carbon dioxide would go up and then come down, go up and come down, and go up and down. And it was going up. But these regular cycles where we have carbon dioxide high, of 1, and then low, the carbon dioxide in the atmosphere is high in the winter and low in the summer. It's winter, summer, because it is when the plants are doing photosynthesis. If the leaves are not correct, we don't have a whole lot of leaves right now, so our carbon dioxide in the atmosphere is what? High or low? High. When we get the foliage out, the plants will start absorbing the carbon dioxide through the leaves, and I forgot to mention that. Plants do not absorb carbon dioxide through the roots, it's absorbed through the leaves. When the carbon dioxide starts being absorbed by the foliage, the atmospheric levels will start to go down.
And for a cactus, does it go through the stem in that case?
It goes through the stem in that case, yeah. Okay, so we already saw that the major difference between monocots and dicots is that monocots have the long linear leaves with parallel venation, and dicots have the broad leaves with what's called net venation. It's like a net. There's another way. So what is inside these veins?
Water.
So we've got tubes that are delivering water and other tubes that are taking away sugars. Vascular tissue is inside those veins. Can't see it real well. We have the stalk, and then the blade, and this is showing the margin of the blade. Then we have a midrib, which is the largest center vein, and then we have side veins. So I wanted to show the basic structure. Here's another one that's a better picture. Whoops, not anymore. The basic structure of a simple leaf. Point out a couple of things. Where the leaf is attached to the stem, you will have a bud. This is next year's bud. And the bud is going to be at the axil between the stalk of this year's leaf and the twig. That's important. You're going to have a bud at the base of every single leaf. There's a bud at the base of every single leaf. Whoops. Oh, okay. This is just showing this picture again to show the presence of the buds. Now that little crook there is known as the axil, A-X-I-L. So the bud there at the axil is the axillary bud. You can think of an axillary, taking your temperature, and axillary temperature is like your armpit. So the axillary bud is the one with that axil there.
Jill,
Yes.
what happens when you have a clasping leaf?
The clasping leaf there's a little bud in there.
There's no axle there.
There is, where it wraps around.
It just doesn't have the petiole of the stalk.
It just doesn't have a petiole, it has sessile leaf attachment. Okay, this is looking at some margins. Relatively simple leaf margins. This is what we use in taxonomy. So an entire leaf margin will have a smooth edge. Serrate will look like a serrated knife. If it has tiny little teeth, it may be called dentate, like little teeth. Crenate is kind of ruffly. Lobe has deep cuts. This oak, another oak, deep lobes. So you're going to see these terms in taxonomic text to help you describe what the leaf looks like, leaf margin. Veins. Dicots have two basic patterns of veins. You may recognize this as Turk's cap. Turk's cap has the classic palmate net venation, where the veins seem to come down to a central spot and emanate out of a central spot, like the palm of a hand. Palmate net venation. And compare that to the pinnate net venation. And the pinnate net venation has that central midrib. Central midrib from which veins come out. So the taxonomic books will say, is it palmate or pinnate? Then you need to understand the difference between a simple leaf and a compound leaf. And this is where we go back to that bud at the axil. A simple leaf, seen here, will have one blade, one axillary bud, one petiole or stalk. And there's the axillary bud. A compound leaf will have several blades. And if you look at the base of them, you don't see a bud because the bud's down here. This is all one leaf. That's all one leaf. That's a compound leaf. This is all one leaf. You look for the axillary bud at the base of each individual leaf. So saying that, and that's a tricky concept. How many leaves are here?
One.
Very good. You didn't fall for it. That's one leaf. Now, do you recognize the species of tree that donated this leaf?
Walnut.
No, walnut would be just a little, probably just, well, it's hard to tell. This is ash. Ash. And here, showing the axillary bud. The petiole is the term for the stalk at the base of the leaf, each of these leaflets. So just look for that bud. That will show you the way. Leaf attachment. Look at all those big fat buds. So here again where we see the alternate attachment and the opposite attachment. So what classic plant out here on Konza Prairie has opposite leaf attachment?
Dogwood.
Dogwood, yep. And here we're seeing it. Sometimes the buds are very small. The buds aren't always going to be big, fat, and juicy. Sometimes they're very small. And this is why you're going to see a lot of taxonomists with a hand lens, getting down on their hands and knees. There you can see the buds nicely. They're at the axil. Okay, what kind of leaves? Simple or compound? This is a compound leaf, so you can see the axillary bud. That is all one leaf. So how many leaves?
One.
The only one that has multiple leaves is G.
Yeah.
How many leaves does G have?
Three.
Uh-huh. Everybody else has one. And that's a difficult concept.
Jill, what terminology do you use for the compound leaf that does have a terminal leaflet and one that doesn't have a terminal leaflet?
Oh, that's not that big. You mean talking about this
Yes,
versus that?
yes.
Gary, terminal leaflet?
In Prairie pinnate. Just say odd number of leaflets.
Yeah.
And that'll usually do it. The one with even numbers, Prairie pinnate, the one with odd number is in Prairie pinnate.
Peripinnate.
That would be trifoliate.
Okay.
Right, that's what I'm thinking
That would be plant taxonomy to the next level.
Yeah.
This is plant taxonomy to get you through the key. All right. And that's not even talking about flowers and fruits. So, that's where we stop. Okay. Good. Okay. I'm not going to turn the lights on because everyone's there. We'll do that.